All right, so this is a reteach of what we learned yesterday in our small groups, only we'll go through a couple examples, and then I'm also going to do a word question, and then we'll go from there. So, this is a reteach of direct and inverse variations. Okay, so inverse variations are, there's always that k, that constant. Okay, it's that constant product. When you guys see it inside a table, you always know the x and the y multiply to the same number every single time. Therefore, it's an inverse variation. The graphs of inverse variations, all of them to some degree resemble something like this. Okay, we'll get to this in a minute. Direct variations look a lot like y equals mx. There's no plus or minus here, but sometimes there are. But in this particular situation, there's not. There's basic. They have a linear function to look like. And again, that constant is kind of like the slope, or what is it constantly increasing by every single time. Like on the table, we know the constant increase is always plus 4, plus 4, plus 4. That's why the k would be the constant. Now, going right here, the graphs of direct variations resemble a straight line. So this question right here says, y varies inversely with x. If y equals 7 and x equals -4, find y when x is 5. So, because we were told, and every time you'll be told if it's a direct variation or an inverse variation, then you'll know exactly which model to follow. So you've got to find that k first. So let's find that k. So 7 times -4 equals k. -28 equals k. First thing's done, now we got to find out what y is when x is 5, because now we know our constant, our k. So, go back into this equation and now just substitute it. Game of substitution. Y equals -28 times 5. Y equals a negative, well there would be a 0 at the end, carry the 4, 140. It's that basic, it's that simple. All right, I want you guys to always know, just follow the process, do the work, done. Done in under 30 seconds per question. That's how simple it is, just follow the process. Over here, this one says y varies directly with x. If y equals 75 and x equals 25, find x when y is equal to 25. Again, this is where they're very similar. In the sense of how to solve them, we've got to find out what that k is. So we do this. We replace the standard equation, 75 equals k times 25 to solve for k every time. Just divide this out. So 3 equals k. Now we can figure it out. Find x when y is 25. So 25 equals 3 times x. And just divide it out. So x equals literally 8 and 1/3. Okay? The rare time I'm cool with you guys using mixed numbers. This is fine. Or you could do 25 thirds. Either way, I'm happy with either. That is it. That is as simple as it is. Back in 1 second. Okay, another example, and then we'll move on to another one. If x and y vary inversely, if y equals 60 when x equals 80, find x when y equals -20. Again, solve for k. So we're using this equation. So k equals 60 times 80. K equals 4,800. Okay? There's that. We know what k equals. Now we got to solve for x when y is -20. Go back into this. So now I'm going to go right here. You see this? Yes. So I got y is -20 equals 4,800 over x. And now, this is one extra step compared to before. We have to multiply the x out of the denominator because you've got to do that. Now this says -20x equals 4,800. And now just divide both sides by -20. And x equals 240. There you go. That's all she wrote, and you're done. Right over here, direct variations. If x and y vary directly, if y equals 28 when x equals 168, find y when x is 108. Again, just solve for that k first. So I got 28 equals k times 168. That's a messed up looking k. Divide that 168 out on both sides. And let's see how this reduces. I believe it does. Maybe not all the way, but I know I can divide out a 4 out of top and bottom to make this into lowest terms. So 168 divided by 4. And then I get this reduced to 5 over 42 equals our k. Leave everything in fraction form. Trust me on this. Now we're going through. So find y when x is 108. So now it's y equals 5/42 times 108. Well, I wonder, let's see what happens here. So 5 times 108 gets us 540. Divide that by 42. So 5 times 108 equals 540. So I know this will reduce y equals 540 over 42. Let's divide out a 4 on top and bottom. No, 4 is not going to work. Let's divide by 2, top and bottom, just to get this first. So this reduces to 270 over 21. I wonder if a 7 divides out of the 270. Divide that by 7, and that doesn't. This is good enough. 270 over 21 is all you need. Just follow the process. Don't get hung up on fractions. Be back in 1 second. Okay, so my last example for today is just a word question looking at a table to figure out if this is an inverse variation, and this will work every time to look at tables and recognize patterns. So first things first, we're looking at average speed and our travel time. So we got speed and travel time are two variables, which means there is a constant, and I want to see if we can figure out what that constant is. So every time you're looking at your tables, always do the first test and see if it's linear. Okay, look at this. All right, as this is going down, see, looks like this is going at a steady rate. Is this also going at a steady rate? And it looks like it goes down by 3.4, then down by 1.6, then down by 1, then down by 0.7. So there is no consistency in that whatsoever. So therefore, it's not linear. Now the next test is to see if this is in fact inverse. So the next test is multiply everything by itself, by x and y, are these two variables. 20 times 10 is 200. 30 times 6.666, which is what it rounded to, is 200. 40 times 5 is 200. 200, 200. So I'm looking at all my questions. What equation relates average speed to travel time? How is the pattern related in travel time to speed shown in this graph? And is the relationship an inverse variation? Yes. Yes, it is, because x and y constantly multiply to 200. So now we know our k, our constant. And it looks like our speed and our time and our distance. So remember, what equation relates speed to travel time? Well, speed is always, and this is how I memorize it, miles per hour. So this really means the per means that the h goes on the bottom. So this is why I always memorize it. Speed always equals distance divided by time. That equation relates to that because that is ultimately your speed. Speed is equal to miles per hour. That's what the per means inside that little thing right there. So that's a little trick for you in the future. What equation relates to average speed to travel time? There you go. We know our constant, our distance is always going to be the same. Okay, our distance is 200. This looks just like one of your examples in your book you're going to see, so that's why I purposely did this. And some of these questions are in there as well. How is the pattern relating travel time to speed shown in the graph? Well, let's graph this. I'm going to put speed over here. I've already wrote this up. Time down here. This is going by 10s. This is going by 1s. I labeled every other one as 2, 4, 6, 8, 10. I'm going to plot this. Travel time is at 10 and 20, so that's right about there. 6.630. 6.630. Okay. It's all just rough estimates. 5 is at 40. Okay. 4 is at 50. And 3.3 is at 60. So I can see that this graph resembles the typical graph we've been seeing. So a way to explain this, you can say, how is the pattern relating travel time to speed shown? Well, as my speed increases, my time shortens. There you go. And that makes sense. As speed increases, time shortens, which makes logical sense. And just like this, as speed decreases, my time gets longer. Okay? So you're going to see some examples like this in tomorrow's work. I want to do a reteach so you guys understand it good. I will see you tomorrow morning or today.